Hello, I am Olale Badmos and this is my YouTube channel. So here you will get mathematics and science lesson videos, difficult concepts made easy through well explained and thorough methods of teaching. To get notifications from this channel, subscribe, like and share. Share to your neighbors, share to your friends, share to that student, share even as a parent to other parents, all right, who have students and children in secondary education. I want to assure you that you are going to get lessons that appeal to the understanding of your words, of your children, of your students, and even you as a student. Thank you. Today we are learning to describe a segment of a circle, to find the length of a chord, to find the perimeter of a segment. So at the end of this lesson, you should have the ability to describe the segment of a circle. So first, what is a segment, or how do we describe a segment from a circle? So you can note this down. A segment of a circle is a figure. It's a figure that is bounded by a chord and an arc. A segment of a circle is simply a figure that is bounded by a chord and an arc. Now, how do we describe that? Now, this is a circle with center O, right? So, what is a chord? In previous class, I've described a chord. What a chord is. A chord is simply a line that is drawn from one end of the circumference to the other end of the circumference. And I also mentioned that a chord can be drawn, from anywhere, from any point on the circumference to the other end of the circumference. So there is no particular point. So, for example, I can decide to draw my chord from here. It's a straight line that is drawn to the other end of the circumference, and it follows no particular order. All right, or it appears in no particular position. Sorry, so you can pick it up from anywhere. All right, any point on the circumference. So this is a chord, and this line divides the circle into two parts. This line, the chord, divides the circle into two parts. So this is a segment. This is also a segment. Now, you observe that one segment has, it occupies a larger area than the other one. So the one with the larger area is called the major segment. This is the major segment, and this is the minor segment. So a chord is a line. It's simply a line that is drawn from one end of the circumference to the other end of the circumference, and it divides the circle into two segments. So the segment with the covering a lower area or covering a smaller area is a minor segment, while the segment that is covering a larger area is the major segment, right? So again, the segment of a circle is simply a figure that is bounded by a chord and an arc. So let's see this. There is a major segment and there is a minor segment. To split this, we are going to have something like this, right? This is the arc. This is the chord. This is the major segment. Major segment. Again, this is an arc. This is the chord, the other part of the circle, and this is the minor segment. The minor segment. So again, a segment is simply a figure that is bounded by a chord. The line, this is the line, this is the chord. Bounded by a chord and an arc. This is the arc. So any figure that is bounded by a chord and an arc is referred to as a segment. It's referred to as a segment. So the chord divides the circle into two not equal parts, into two unequal parts, right? But then there is a chord called a diameter. I've also mentioned this in previous classes, that a diameter is also a chord because it is drawn from one end of the circumference to the other end of the circumference. The only difference is that the diameter passes through the center. It's a line that passes through the center of the circle. So this is the equal part, right? But then there is a chord called a diameter. I've also mentioned this in previous classes, that a diameter is also a chord because it is drawn from one end of the circumference to the other end of the circumference. The only difference is that the diameter passes through the center. It's a line that passes through the center of the circle. So this is the diameter. This is the diameter. It is also a chord. All right. It's different from every other chord because it passes through the center of the circle. Right. I hope that is clear. So we've been able to describe a segment of a circle. Next is to find the length of a chord. How do we find the length of a chord? It's very simple. Now, we'll need to derive the formula for calculating or finding the length of a chord. Now, first thing is to draw a circle. We'll draw a circle with center O, right? Now, this, again, that's a chord. Now, we are going to draw the radii. And one thing about geometry is that you are allowed to extend, you are allowed to reproduce. So as long as the figure, all right, the line that you are reproducing conforms with the operation, basic operation, and it agrees with the basic operation of geometry, that's fine. As long as it obeys the rules and theorems of geometry, that is fine. So here we have a chord. But then as part of circle geometry, there is radius, right? So radius on this part, radius on the other side. So we have drawn two radii to the chord, right? Another line to draw in order for us to be able to find the length of a chord is the perpendicular bisector. Now, the perpendicular bisector is simply a line that divides the chord into two equal halves. Or a bisector simply is any line that divides the other line into two equal halves. The reason this is perpendicular, it is because it is at 90 degrees, right, to the chord. At 90 degrees to the chord on both sides. So that's why it is called a perpendicular bisector. So with center O, from center O, we draw a perpendicular bisector to the chord, right? Now, having drawn that, don't forget this is radius, this is radius. Now, we want to find the length of this chord, AB. The length of chord AB. So with this perpendicular bisector, let's label this as C. So let's label this as C, so we can as well say that there is the length of chord ACB, alright, chord ACB. Now, from because of the perpendicular bisector that we have drawn, right, it has divided the chord into two equal halves. So because of that, we have two right angles. We have two right angles here. So what I'm going to do is that I'm just going to pick any of the two right angles. And there is something else also to take note, right? That these two right angle triangles, these triangles are not just right angle triangles, they are also isosceles. Now, what is an isosceles triangle? It's a triangle that has two sides equal. Two of the sides of an isosceles triangle are equal. So let's see that. So here we have a right angle triangle. We have a right angle triangle. So the perpendicular bisector has divided the chord into two equal halves. So because of that, we have two right angled triangles. we have two right angled triangles. So here, this is radius, right? This is center O. I'm picking I'm picking triangle OCA or AOC, triangle AOC. So this is A, this is C, all right? Triangle AOC, triangle AOC, and this is the radius. So let AC and BC be the length of the chord. Let AC and BC be the length of the chord. Alright, so again, let AC and BC be the length of the chord. Don't forget, this is a chord, right? The length of the chord ACB. So AC and BC, right, represent the length of the chord. Now, we want to find the length of this chord. So how again do we go about that? I've taken one of these two right angle triangles. I've taken one out, that's triangle AOC. Triangle AOC. This is triangle AOC. I'm going to import that here. So we have a triangle, right? A right angle triangle. This is C. This is O. This is A. This is radius, right? The radius. And let AC be Y. Let AC be Y. So if AC is Y, right, BC also will be Y. If AC is Y, BC also will be Y. Why is that? The perpendicular bisector divides the chord into two equal halves. So whatever you have on this side, whatever the value of AC is, alright, which is Y in this case, it's unknown. The same also will be on the other side. That's for BC, it's also Y. So pick one of the two right angle triangles and solve. Now there is something else to take note of, which is the angle subtended at the center of the circle. Now before now, we've been able to see that the angle subtended at the center of the circle is theta. Now because of the perpendicular bisector, right, that divides the length, it is drawn to divide the chord into two equal halves, it also divides this angle, the angle at the center. Don't forget, it is a bisector, right? A bisector divides an angle or a line into two equal halves. So if the angle at the center, subtended at the center, is theta, now if it divides into two, right, let's say 1 theta. So if you divide 1 theta into 2, that means you're going to have half theta plus half theta to make 1 theta. It's like you have an orange, right? You have an orange. So when you divide an orange into 2, you are going to have half, right? Half of it, 1 half, then the other half. So 1 half and the other half will come together, it's added, both are added together to give 1 orange. So in the same way here, this is theta, right? 1 theta. It's an angle subtended at the center of the circle. So theta is divided into 2. So we're going to have half theta plus half theta. So there is 1 half, there is the other half. So that means that one angle here will be theta over 2. That's half theta. This other one too is theta over 2. So that means that since I've picked out triangle AOC, which is one of the two right angle triangles, the angle here, right, will be theta over 2. So I have the angle here, right, is theta over 2. So how then do we find AC? AC, which is 1 half of the length of the chord. How do we find AC? Because once we are able to find 1 half, it will be easy for us to find the other half because both of them are equal. So once we find Y, right, the other side of the chord, which is BC, will be the same thing. Now let's see this. So using trigonometry or by trigonometry, and we're using trigonometry because this is a right angle triangle, right? Now the angle at O is theta over 2. So take note of the sides that we have, right, that are known. That's relative though, even though they are not known, they are knowns. Y and and R. That is, we are concerned with these two sides. So this side AC, which is Y, is opposite to the angle. And this side is the hypotenuse side, which is the longest side of a right angle triangle. Right? So now that we have the opposite side, we are concerned about the opposite side. We are also concerned about the hypotenuse side. So which trigonometric ratio, right, is this? This is sine. If you still remember your SOHCAHTOA. SOHCAHTOA. So this is sine theta. In this case, theta over 2, because that's the angle of consideration. Sine theta over 2 is equal to opposite over hypotenuse. Sine theta over 2 is equal to opposite, right, over hypotenuse. So we are going to write sine theta over 2 is equal to opposite. What's the opposite side? What's the value of the opposite side here? Y over hypotenuse, R. So let's write this as sine theta over 2 is equal to Y over R. So this also can be over 1. So by cross multiplication, 1 times Y is Y, and that's equal to R sine theta over 2. So the value of one of the side of the chord, one of the side, right, of the length of the chord is R sine theta over 2. R sine theta over 2, right, one of the sides. So now that we have the value of Y, and we have seen that the length of the chord here is Y plus Y, right, that's 2Y. So since we have the value of 1Y, right, 1Y in quotes, which is R sine theta over 2, what then will be the value of 2Y? Because 2Y is the length of the chord. And don't forget here, I wrote that let AC and BC be the length of the chord. So Y is AC, right? Y is AC. So if AC is R sine theta over 2, which is one of the side of the length of the chord, BC also is equal to Y, which also will be R sine theta over 2. So what we need to do to find the length of the chord is to add Y to Y. So if Y is R sine theta over 2, we had another R sine theta over 2. So let's work that out. Y equals R sine theta over 2. So since the length of chord is Y plus Y. Now substitute R sine theta over 2 for Y. So Y plus Y. So we're going to have R sine theta over 2 plus R sine theta over 2. This will give 2R sine theta over 2. Therefore, length of chord in a circle is 2R sine theta over 2. So you don't have to cram the formula, alright? Just know how it goes, know your dimensions, and take it step by step, one after the other, and you'll be able to calculate the formula by yourself in case of an examination condition, where if you cram it, you may forget. But if you know your dimensions properly, you know how to describe a circle very well, all right? And with this explanation, right, you can derive your formula by yourself and use it in the examination or whatever situation you need to use it. So I hope you understand. Thank you. All right. So I hope that lesson was effective enough to help your understanding and to help you learn better. I want to believe that you've gotten better than before. So if you have not subscribed, do well to do that. Subscribe, like, and share. Share to everyone around you so you can get more notifications. Thank you. Bye.